Hi friends, today I'm going to discuss about the acidic character of alcohols and phenols. We know that acids are the species which have the ability to lose H plus ion. In alcohols, OH functional group is here, so that the bond between O and H breaks. As a result, H plus ion will be losing easily. So alcohols are acidic in nature. And these two reactions are proving the acidic character of alcohols. The first one is ROH, which is aliphatic alcohol, which is on reaction with a metal like sodium. Any metal can be taken. So the OH bond breaks so that hydrogen atom will be replaced by sodium atom. So we get RON, RONA, and hydrogen will be leaving as hydrogen gas. Similarly, if it is phenol, again OH bond breaks, hydrogen atom will be replaced by sodium atom. We get benzene with the ONA, which is called a sodium phenoxide, and hydrogen will be leaving as hydrogen gas. So these two reactions proves the acidic character of aliphatic and aromatic alcohols. So both aliphatic and aromatic alcohols are acidic in nature because of the presence of OH functional group. Aromatic alcohols are called as phenols, that you know already. So this is the preliminary introduction, and now we are going to compare different type of alcohols, the acidic character among primary, secondary and tertiary alcohols. We know that primary alcohols are RCH2OH, one alkyl group combined with CH2OH. Secondary is R2CHOH, there are two alkyl groups. And tertiary is R3COH, there are three alkyl groups. And alkyl groups are showing plus I effect. There will be plus I effect, which is also called electron releasing effect. All alkyl groups like CH3 or C2H5 are electron releasing effect. So RCH2OH, when this alkyl group releases electrons to this carbon, electron density means the direction of electron movement is from this alkyl group towards this oxygen side. So that electron density of this oxygen increases. Electron density of the oxygen increases. So as electron density of oxygen increases, the polarity of OH bond decreases. The bond becomes less polar. Which bond? OH bond becomes less polar. If the bond is less polar, it represents the bond doesn't break easily. Breakage of the bond, breaking OH bond is difficult. You understood the point? When electron density of oxygen increases, why? Because electron density increases, alkyl groups are releasing electrons to the oxygen atom. So oxygen's electron density increases, polarity of OH bond decreases, so that the breaking of OH bond is difficult. If OH bond is not breaking easily, it represents H plus ions won't be losing easily. It is difficult to lose H plus ion, won't be losing easily. Got it? It means it is less acidic. Because as acids are the species which has the ability to lose H plus ion. But in this case, because of the presence of alkyl group, electron density increases, polarity of OH bond decreases, breaking is difficult, so H plus is not losing easily, so it becomes less acidic. This is the basic concept. Now the same concept I am going to apply in different amines like primary, secondary and tertiary. You see in tertiary amine there are three alkyl groups. All the three alkyl groups will be releasing electrons to this oxygen atom. So electron density of this tertiary alcohol, electron density is maximum. So that the polarity of OH bond in tertiary is minimum, very less. So H plus ion will not be losing there. It means acidic character will be minimum, very less, least. We can say that tertiary acidic character is least. When you compare primary, secondary and tertiary, primary is the one which has only one alkyl group. So that electron density of that is there, but compared to secondary and tertiary, electron density of oxygen in primary alkyl primary alcohol is very less. So that when you compare the acidic character between primary, secondary and tertiary, we can conclude like this. Primary is greater than, secondary is greater than tertiary. This is how we can conclude. Why? Because in primary only one alkyl group. Tertiary there are three alkyl groups. So alkyl groups plus I effect is determining the acidic character among alcohols. This is one way of comparison between different alcohols, especially aliphatic alcohols. Now let's compare the acidic character between aliphatic alcohols and aromatic alcohol. Aromatic alcohols are also called a phenol. So aliphatic alcohols and phenol. Aliphatic alcohols are the one which OH is attached with the alkyl group. So normally, if there is ROH, the bond between O and H breaks and it gives RO minus. RO minus is alkoxide ion plus H plus. This is the product after losing H plus ion from ROH. But if it is phenol or aromatic alcohol, the bond between O and H breaks. H will be losing as H plus. As a result, we are getting benzene with the O minus. This product is called a phenoxide ion. So phenoxide ion is the product if it is aromatic, but RO minus or alkoxide ion is a product if it is aliphatic. And we will check which product is more stable. Is it alkoxide ion or phenoxide ion? So for that we need to take the effect resonance effect. So because of the benzene ring in phenoxide ion, it is resonance stabilized. These are the resonating structures of phenoxide ion. So the electron pair from oxygen is moving to the benzene ring so that the benzene is getting negative positions in ortho, para and again ortho position. So already you have studied how to draw the resonating structures and all. So that part I am not discussing. Anyway, you need to understand the phenoxide ion is resonance stabilized. So it is more stable. Phenoxide ion is more stable. Why? Because it is resonance stabilized. But alkoxide ion, it is R only. It is not a benzene compound. It is R aliphatic. So it is less stable. So the one with the more stable product will be having feasible reaction. It means phenol to phenoxide ion is more feasible than aliphatic alcohol to alkoxide ion. So because of that, we can say that phenol or aromatic alcohols are more acidic than aliphatic alcohol. Okay, so the first comparison is between different types of alcohols like primary, secondary and tertiary. So we concluded primary is more than that of secondary than tertiary. Second comparison I made between aliphatic and aromatic. Here we concluded aromatic alcohols are more acidic than aliphatic alcohol due to the stability of phenoxide ion. Third, I am going to compare between different types of aromatic alcohol. Because in aromatic alcohol, sometimes CH3 group can be there as a substituent in the para or ortho position. Sometimes there will be NO2 group as a substituent. So NO2 group is electron withdrawing group, but CH3 group is electron releasing group. If electron releasing group is there, it releases electrons to the benzene ring. So benzene will be giving electron to the oxygen atom. So oxygen electron density increases. Electron density increases, the concept is polarity will decrease. As polarity decreases, the breaking of OH bond will be less, decreases. So H plus ion losing will be decreasing. So that acidic character also decreases. Or everything is decreases because of increased electron density. But electron withdrawing group, it pulls electrons from the benzene ring. So benzene will be giving electron to the electron withdrawing group. So benzene will be pulling electron from the oxygen atom. So oxygen electron density decreases. So that polarity increases. So breaking of OH bond increases. H plus ion losing will be increases. So acidic character increases. So we can say that if there is electron withdrawing group, it increases the acidic character, but if there is electron releasing group, it decreases the acidic character. So this is the third comparison between different types of substituted phenol. So if only phenol is there, there is no substituent, the position of that phenol comes in between that of electron withdrawing group and electron releasing group. So these are the three comparisons to understand about the acidic character between different types of alcohols. So let's do one or two questions to understand this more. Arrange the following compounds in the increasing order of their acidic strength. First question, in that the compounds are propan-1-ol, 2,4,6 trinitrophenol, 3-nitrophenol, 3,5-dinitrophenol, then phenol, then 4-methylphenol. So first of all, you have to understand which is aliphatic and which all are aromatic. Only one aliphatic is there, which is propan-1-ol. We compared like aliphatic alcohols are less acidic than aromatic alcohols. Aromatic alcohols are always more acidic. So here propan-1-ol is the only one which is aliphatic in nature, that comes at last. At last, if it is in the increasing order, we have to start with the propan-1-ol. This is the least acidic. Then aromatic. Aromatic we studied if there is withdrawing group is most acidic, releasing group is less acidic. 4-methyl is releasing. So that will be after this propan-1-ol. 4-methylphenol. Then the remaining compounds like trinitro, 3-nitro and 3,5-dinitro. Then phenol. Phenol is the one without having any electron withdrawing or releasing. So after 4-methyl, we can write phenol, the one without having any of these substituent. Then we can arrange all these nitrophenols based on the number. So in 3-nitrophenol, only one nitro group is there. So that comes after this. Then 3,5-dinitro. There are two nitro group. Electron withdrawing groups are increasing the acidic character. That's what. Because of the increased number of that group again increases the acidic character. So the most acidic among this is 2,4,6 trinitrophenol. Got it. So this is the normal pattern of asking question from this session. So in CBSE mainly two types of orders can be asked. One is this only, order of alcohols or phenols based on their acidic character. Similar to this one, another concept is there which is regarding the basic character in amines. So that video is already there. I will be giving the link in the description box. Another one where there is a reasoning question. Explain why orthonitrophenol is more acidic than orthomethoxyphenol. So the same reason like the one which I said, like nitrophenol is having orthonitrophenol, so withdrawing group is here. Here methoxy is electron releasing group. So that same reason which I discussed already. So based on that you can understand, or you can write the points like if there is electron withdrawing group is there, electron density decreases, polarity decreases, so that OH bond, electron density decreases, polarity increases, OH bond will be increasing, breaking easily, H plus ion will be losing easily. Like that you can explain the answer. So thank you all.